2.6 number 46. We're given the inequality 3 times the absolute value of 4 minus 5x is less than or equal to 9. And it says to graph this and see what the values are. If I subtract 9 from both sides, I will get a more sane thing to graph. 3 times absolute value of 4 minus 5x minus 9 is less than or equal to 0. So anything below the x-axis here satisfies this equation, but it also satisfies my original equation since all I've done is subtracted 9 over to the other side. It crosses the x-axis at about 0.2 and about 1.4. So anytime this is below the x-axis, it satisfies this inequality. So x should be greater than or equal to 0.2. Let's draw that a little bigger. Right. X is greater than or equal to 0.2, but less than or equal to 1.4 is what the graph is telling us. Right? So let's see if we follow through the algebra, what we're going to get from here. Now remember, the absolute value, we need to break this into 2 separate inequalities. But the first thing I want to do, this is a 3 times out here. This 3 doesn't have anything at all to do with my absolute value. So if I go through and divide both sides by 3, I can make this a little simpler to start with. So I'm going to multiply both sides by a positive 1/3. It's positive, so it's not going to change my inequality. This 3 will cancel with that 3, giving us a simplified 4 minus 5x is less than or equal to 9 times 1/3 is 3. All right, so this is the thing that I'm going to work with. I'm going to have a positive and I'm going to have a negative. The positive says that the thing inside is positives, right? So 4 minus 5x is greater than 0. Greater than or equal to 0, okay? So that means if that's the case, if we're in that condition, we can just drop our absolute value signs. So we'll get 4 minus 5x is less than or equal to 3. Okay? Now there's a couple ways of doing this. I could subtract the 4 over to the other side and then divide through by a negative 5. But in this case, I'm actually going to add the 5x to both sides and I'm going to subtract 3 from both sides. I do that so I don't have to worry about flipping my inequality. I'll get the same result anyway, but I don't have to do that extra step. So if I subtract 3, cancel, 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 cancel. 4 minus 3 is 1, is less than or equal to 5x. Okay? And now I can go through and divide by 5, but it's a positive 5, right? So multiply by 1/5, multiply by 1/5. The 5 will cancel there. 1/5 times 1 is 1/5. So x is greater than or equal to 1/5, but 1/5 is exactly 0.2. So we have this side of the inequality already. Okay? Now we should certainly check to see if 4 minus 5x is greater than 0. If x is 1/5, 5x is 5 times 1/5, which is 1. 4 minus 1 is 3, and 3 is positive. So this is in our range. Okay. Now on the negative side, we're going to have 4 minus 5x is less than 0. Okay. And on the negative side, we have to multiply our absolute value. We drop the absolute value, but multiply everything on that side by -1, right? So we're going to have negative 4 minus 5x is less than or equal to 3. In this case, I want to distribute this negative sign through. So I'm going to get -4. Negative times a negative is a positive 5x is less than or equal to 3. And now I want to add 4 to both sides. Plus 4, plus 4, cancel, cancel. Get 5x is equal to 3 and 4, or less than or equal to 7. And now if I divide both sides by 5, multiply by 1/5, I'm going to get x is less than or equal to 7/5. 7/5 is the same exact thing as 1.4, which is exactly what I got from the graph for the other side. Okay? And I should certainly check to see if this is less than 0. If x is 7/5, 5 times 7/5 is -7. 5 times 7/5 is 7. -7. 4 minus 7 is -3. -3 is less than 0. So that is in the range. So our overall region where this is true is between when x is between 0.2 and 1.4, including the endpoint.